Okay, this question asks to find the series n equals 0, infinity, negative 1 to the n, Bn is either converging, absolutely converging, divergent, or conditionally converging. Okay, so we're given that limit of n goes to infinity, Bn plus 1 over Bn, it's this, is equal to 1 over 3, right? So if you want to check the absolutely convergent part, we can do n equals 0 to infinity, negative 1 to the n, Bn, absolute value. So this is n equals 0 to the infinity, Bn, right? And for this one, since we know this, we can just use the ratio test, right? Ratio test, limit goes to n goes to infinity, Bn plus 1 over Bn is equal to 1 over 3, infinitely, absolute, and with the absolute value, which means if you use the ratio test, this value is 1 over 3, right? And this is less than 1, that means the ratio test and test can tell you it's converging, right? But also we have put the ratio, absolute value and proved that the ratio test is converging, so this means it is absolutely converging. Because we put the absolute value to get rid of the negative sign, and you get Bn, and then you put the ratio test, Bn plus 1 over Bn, and we know that we are given as 1 over 3, which 1 over 3 is less than 1, so by the ratio test, it is converging, and since we put the absolute value, it is absolutely converging. So this must be absolutely converging, so the answer is A. Okay, this question asks to find for which n is the following true. So this is saying, basically this equation is saying it's less than or equal to 0.01. So we know we have to use the alternating series estimation, because we are given the value is something is less than, or something is less than some value, which is in our case is 0.01, and also we are given that it's alternating series. So it's going to be Sn plus 1 is less than or equal to 1 over 100. So Sn plus 1 term is basically negative 1 to the n plus 2 over n plus 1. Negative 1 n plus 2 is always going to be positive value, so it's going to be 1 over n plus 2, 1 over n plus 1. So 1 over n plus 1 is less than or equal to 1 over 100. This is cross multiplication, n plus 1, 100. So n is greater and equal to 99. So the answer is D. Okay, this question asks to use the ratio test to determine conversion or not. So we're given k equals 1 to infinity, k factorial squared over 2k factorial. Okay, and then we have to use the ratio test. That means we have to add plus 1 in the term. So it's gonna be k equals 1 to infinity, k plus 1 factorial squared over 2k plus 1 factorial. And this goes to infinity, limit of k goes to infinity, sorry, and divided by the original. So it's gonna be multiplied by the reciprocal. So that means it's gonna be k factorial squared and then 2k factorial. Limit of k goes to infinity. And we don't need this part, sorry. So this means basically you can write this as k plus 1 squared and then k factorial squared, right? Because we have a squared, so k plus 1 comes out, and then we left with k factorial squared, so in the way that we can like cancel out the k factorial squared in later. So I wrote it like this, and then this is going to be same as 2k plus 2 factorial times 2k factorial over k factorial squared, right? K factorial squared canceled out, and this is limit of k equals to infinity, k plus 1 squared over 2k plus 2 times 2k plus 1 times 2k factorial, and we have 2k factorial over 1. So 2k factorial can be cancelled out, so ultimately we are just left with k plus 1 squared and 2k plus 2 and times 2k plus 1, right? So limit goes to k to the infinity, k plus 1 squared, and this is 4k squared plus 6k plus 2. We don't really care about the rest of the term, we just care about the highest term, highest power, right? So limit goes to k to infinity. This is going to be k squared plus 2k plus 1, 4k squared plus 6k plus 2 we don't really care about this part, because if it goes to infinity, the highest term would be matter and the rest of the term would be just very minimal, trivial number. So it's gonna be just converting to 1 over 4, because we have 1k squared and 4k squared on the bottom. So this is 1 over 4 and this is less than 1, so it is converging. So R is less than 1, therefore series converges. So the answer is C. Okay, this question asks which of the following statements are true. For this one, you just have to kind of remember things. We know that it's like we have to remember this two statement. If the sequence diverges, then the series diverges. And if the series converges, sequence converges. So using the fact that we have these two statements, sequence converges, then series converges, that's not the right order. It's sequence diverge and series diverge. Sequence diverge, series diverge, so 2 is right. And if the series converge, so sequence converge, series converge, sequence converge, so 3 is right. So 4 is not right, because it's not the order that we want. So this is going to be 2 and 3, so the answer is B. It's basically you have to remember which statement that you use, and you can't just change the order, like series diverges and sequence diverges. That's not how it's stated. It's a series converges, sequence converges. That's not the same. That's why we have our answer as B. Okay, this question asks what is the interval of convergence. Okay, I'm gonna use the ratio test to solve it. So ratio test says limit of n goes to infinity, you add a term, n plus 1, x minus 1, n plus 1, over n plus 1 squared plus 1, divided by the original and multiplied by the reciprocal. So n x minus 1 to the n power, and then n squared plus 1. So since this power is the same, so this is n squared, right? And this is also n squared plus 1, so we don't have to worry about this part. So I'm going to just cancel out. So limit n goes to infinity, n plus 1 over n times x minus 1, n plus 1 over x minus 1, n. N plus 1 and n also have the same power, so we don't have to worry about that part as well. So this is limit of n goes to infinity, x minus 1 times n times x minus 1. I'm writing this way so I can get rid of the x minus 1 to the n power, because we have numerator and denominator have the same value. So I can cancel this out, and then we're left with just x minus 1. But we know that it's converging, so it's going to be x minus 1 is less than 1. So x minus 1 is between -1 to 1, x is from 0 to 1 to 2. And then if we see our option, it's going to be either B or E, not C, D, A. And we know that 0 is already in the square bracket, so we don't have to check the 0. I mean, if you want to, we could check the 0. Okay, let's check 0, then x equals 0. Then let's plug it in our equation, original equation. N equals 1 to infinity. This is going to be n times -1 to the n over n squared plus 1, right? And then this is just the alternative series test, right? So A is T. If you add that, then it has to be decreasing first, right? Over n squared plus 1. This is decreasing, right? This is going to be just 1 over n, 1 over infinity. It's equal to 0. So, I mean, we're checking it's not decreasing. We're checking whether the limit goes to 0. And this does goes to 0, right? 1 over infinity equals 0, and this is because the p-series test. And now we have to check the decreasing part. So n over n squared plus 1, this is 1 over n. So if it goes to infinity, this value will be decreasing, not increasing. So that checks the right. That is checked. So x is 0 is a square bracket. And now let's check x equals 2. If we plug in x equals 2 in our original equation, this is going to be n equals 1 to infinity, n times 1 to the n over n squared plus 1. This is same as just n equals 1 to infinity, n over n squared plus 1, right? So if you plug it in this one, by the p-series test, it's going to be 1 over n, right? Which 1 over n as the p equals 1, and and then p-series tests that say that it has to be greater than 1 to be converging, right? So this is p equals 1, so it's diverging. So the brackets, this wouldn't be the brackets. This would be the parenthesis. So we have 0 to 2 parenthesis. So this is going to be option E. So the answer is E. Okay, this question asks which of the following series the ratio test is inconclusive. Okay, so let's check the ratio test for all of those. So 10k plus 1 over k plus 1 factorial and divided by the original multiplying by the reciprocal. That means, right? So I said divided by the original, which means the same as multiplying by the reciprocal. So I'm going to write it as 10k and then k factorial right there. So this is, and k goes to infinity, limit of k goes to infinity. This can be written as 10k times 10 over k plus 1 times k factorial, and then times k factorial over 10k. I'm writing this way so I can cancel out the terms. 10k cancel out, k factorial cancel out. So we're left with 10k plus 1. And then 10k plus 1, if the limit of k goes to infinity, this is 10 over infinity, which is 0, which is less than 1, so it's converging. So 1 is right, so that means 1 A, D is going to be our answer choices, and B, C, E are not the right ones. Okay. Oh wait, it's asking the inconclusive, sorry. So it's not going to be that, so it's converging. So our 1 is converging, so it's not inconclusive. So 6 is not 1, so 1 shouldn't be included because it's asking it's inconclusive. I read the question wrong, I guess. 2, we check k equals 1 to infinity, 1 over k squared. So we're going to check whether limit of k goes to infinity if you add the k plus 1 term. So not add plus k plus 1, but like plug in the k plus 1 term and then divide it by the k term. So k 1 over k plus 1 squared divided by the original and multiply by the reciprocal. This becomes k squared and the k plus 1 squared. Since they have the highest power of 2 in both numerator and denominator, it's going to be converging to 1, which is, then it's going to be inconclusive, because when you get the 1 for ratio test result, you get inconclusive as the final answer. So that means 2 is our answer choice. That means B or E is going to be our answer choice. Okay, let's check the 3. So k equals 1 to infinity, ln k over k. So if you put the ratios test in, you have to put the k plus 1 term, ln k plus 1 over k plus 1, and then divide it by the original, so multiplying by the reciprocal, so ln k over k, k over ln k. K and then k plus 1 have the same power, so this one will cancel out, and ln k plus 1 and ln k also have the same power, because if you plug in just ln, just suppose the k is 1 or k is 2 or something like that, then ln 2 and ln 3. So they are just the constant terms, so they have the same power. That means this is just going to be converging into 1, and if it converges to 1, ratio test has said it's inconclusive. So this 3 is also inconclusive. So the answer is E. Okay, this question asks whether it's converging, absolutely converging, conditionally converging, or diverging. Okay, let's check our option A, or 1. Cosine of n over n squared plus 1, and n equals 1 to infinity. Okay, so let's check this by absolutely converging first. If we put the absolute value, this is going to be cosine of n over n squared plus 1, and we also know that cosine of n is bounded from -1 to 1. So if you put the absolute value of those, then cosine of n will just be 1, right? Because the maximum that it can go to is 1 and -1. Maximum it can go to is 1, but if you put the absolute value, either -1 and 1 will be just going to be 1, right? So this can be just written as 1 over n squared plus 1, right? And then we know that 1 over n squared plus 1 is converging by the p-series test, and p in our case is 2, which is greater than 1, so it is converging. So 1 is right. So one is not right, one is absolutely converging. That means either gonna be A or C, not D, B, D, E. Okay, we have that. Now let's check 2. 2 is n equals 1 to infinity, negative 1 to the n over 2n. Like what we did before, we can just check the absolute convergent first. Absolutely convergent. So if you put the absolute value on the term, this becomes 1 over 2n, right? And 1 over 2n, since n is power of 1, this is going to be diverging by the p-series test. Okay, so it's not absolutely convergent at least. And our option also said it's going to be either divergent or conditionally convergent. So now let's plug it in the, let's do the term without the absolute value. So negative 1 to n over 2n. Since the sign is alternating, this is going to be alternative series test, AST. So if you remember your alternative test, it has to be either decreasing or limit of k goes to infinity, or in our case it's going to be n goes to infinity, and the term has to equal to 0, right? So let's check. So 1 over 2n, if the limit of n goes to infinity, this term will be smaller, getting smaller value, right? So it's going to be decreasing for sure. And we can check that by plugging in n equals 1, then it's going to be 1 over 2, n equals 2, 1 over 4. So you can see that it's going to be keep decreasing. So it is decreasing. So 1 is right. And then 2, if the limit of n goes to infinity, this is converging to 1 over infinity, which is 0. So this is also getting 0. So it is convergent. So by the AST, it is converging, but it fails the absolutely convergent. So it's going to be conditionally convergent because it's only working as the alternative series test, not the absolute value. So this is going to be answer choice C. Okay, this question asks to evaluate the following terms. So I know this is all the multiple of 5, so I'm going to group them by 5, 1 minus 2 over 3, plus 4 over 9, plus blah blah blah. And 4 over 9 is the 4 over 9 is the same as 2 over 3 squared, right? So you can rewrite this as 5, 1 minus 2 over 3 plus 2 over 3 squared, blah blah blah. So it's like the ratio is looking like 2 over 3, right? Because it's the multiple of 2 over 3, but there's a negative 1 sign. So you can write this as 5 times k equals 0 to infinity. Some kind of ratio, like the sign is changing, so it's going to be negative 1 times k times 2 over 3 k. If you do that, since they have the both same power of k, so you can write this as 5k equals to 0 to infinity, negative 2 over 3k. Now let's check whether this is actually working. So k equals 0, then it's going to be 1 times 5, which is 5. K equals 1, then it's going to be negative 2 over 3 times 5, which is negative 10 over 3. So we see that the sign is also changing, but also at the same time the value is right. So this means this equation can work for to find our geometric series sum. And we know that geometric series sum is S infinity is equal to a over 1 minus r. A is the first term, and r is the ratio. In our case, the ratio is negative 2 over 3, and the first term would be, when you calculate this part, don't include the 5, because many people might think the first term would be 5, but like, since we're just looking at k equals to 0 to infinity, negative 2 over 3k, this equation, I can write this again. So we are looking at k equals 0 to infinity, negative 2 over 3k. We are just looking at this part, not the 5. So that means our first term is negative 2 over 3 to 0, which is 1. And then, so many people might wonder, where do we incorporate the 5? When we calculate this part, like this equation first, and then multiply by 5, we're going to do that. So let's do this part first. So if you find the geometry series sum, this is going to be a is 1 minus 1 minus r, 1 minus r, so minus 2 over 3, which is 1 over 5 over 3, which is same as 3 over 5, right? And then you have to multiply by s of infinity because we have the 5 outside here. So this is 5 times 3 over 5. So this is equal to 3. So the answer is A. Okay, number 9. So it's asking which of the following is the third order Taylor polynomial. So if you remember your Taylor polynomial equation, it's going to be something like fn plus f prime of n x minus a over n, a to the n power over 1 factorial plus f double prime of n x minus a over, not n power, this is going to be 1, square power over 2 factorial, and then f triple prime of n x minus a to the quadruple cube power over 3 factorial. And we know that a is 0, so this part is just 0, right? I'll just erase it, so it's going to be simple to see it. There we go. A is 0, and also we know that it's going to be just like third powers, which is why I only wrote it until to 3, but if you had to do more, then it's going to be there's more added in here. But since we're only looking for third order, so we don't have to write the rest. And we know that it's at n is 0, right? Because we're given the values are all at 0. So this is going to be f of 0 plus f prime of 0 x over 1 plus f double prime of 0 x squared over 2 factorial plus f triple prime of n x cubed over 3 factorial. And f prime of 0 is 7 and f0 is 0. So this is going to be 0 plus 7x plus f double prime of 0 is 0. So this is cancelled out. And then f triple prime of 0 is 2. So this is going to be 2x cubed over 3 factorial. This is same as 7x plus 2x cubed over 3 times 2 times 1. 2 cancelled out. So this is 7x plus 7 cubed over 3. So that's same as A. So the answer is A. Okay, this question asks to find the series whether it's divergent or not. So we see that it's k squared e to negative k3, so k cubed power. So since k cubed power is like 1 power bigger than the k squared, we know that we can use integral test. So let's do that. So integral test of 0 to infinity k squared e to the negative k cubed, and then dk. So if you put u as k cubed, then du becomes 3k squared dk. du over 3 is equal to k squared dk, right? So this becomes 3 over du e to the minus u, right? And then our new bound would be u1 0 cubed, which is 0, u2 infinity cubed, which is still infinity. So it's like 0 to infinity, 3 over 3 e to the minus u. So this becomes negative, not negative, 1 over 3, 0 to infinity, e minus u du. And if you integrate that, this becomes 1 over 3 e minus u minus 0 to infinity. This is minus 3, 1 over 3 e to the negative infinity plus 1 over 3 e to the 0. This goes to 0, this becomes 1 over 3. So there is a value that converges, so this is going to be convergent by integral test. But let's check the A, B, and E. So for E, geometric series, we can't use a geometric series, right? Because let's see, k squared e minus cube, and then it's going to be k equals 0 to infinity. So this is not in the geometric series form. It's not, you can't find the ratio, so it's not E. And then comparison test, let's see that. So k squared e to the negative k cubed. So if you compare it with 1 over k, how are you going to compare it? This is not in the format of like 1 over k, since this is not in the denominator. You could put that in the denominator, but okay, I will put that k squared equals e to the k cubed. But this is not the same format. So if you do that, it's not possible to do it. This is not a similar format as this. If it was k squared over k cubed, then it would be possible to compare it. But this is not in the format like that, so it's not possible. And also this one, ln k over k and k squared over e to the k cubed. This is not also the similar like comparison format. They don't have a e and they don't have a ln, so this is not possible to compare. So this becomes just d by the integral test. I don't know how to explain a, b, c, and e are not the right answers, because a, b, it's kind of like clear that it's not having like e on the bottom, and they have ln for their value, so it's not like in the similar format. And c obviously it's not working, because if you actually take the integral test, that's not what we get. The result is not diverging. And also e is also not in the geometric series format. So other than that, I don't know how to explain further for this question that d is the answer, because it's just the instinct that you see minus k cube is the 1 power bigger than k squared, and you can use sub to solve it. So yeah, the answer is D then. Okay, this question has to find the remainder term of nth order, and it's from x and e, and it's x and 2. Okay, so remainder theorem says Rn of x is equal to fm plus 1 c x minus a m plus 1 over m plus 1 factorial. Okay, and our a is 2, so this becomes fm plus 1 c x minus 2 m plus 1 over m plus 1 factorial. And if you look at our function, fx is e to the negative x, negative 3x. F prime of x is negative 3e negative 3x. F double prime of x becomes 9e to the negative 3x, which is same as negative 3 squared e to negative 3x. So we know that we are constantly having that negative 3 term is getting squared, right? So you can write this as actually negative 3 m plus 1, and then e times negative 3c as to represent this part, fm plus 1 times to the c power, because we have the negative 3 as constantly like getting squared, so which is why you put negative 3 to the m plus 1 power to make it equal, and then times e to the negative 3c, and then over m plus 1, and then x minus 2 m plus 1 plus 1, right? So this format, so we have to find the one that's similar to that one. So this one would be negative 3 m plus 1, not this one, this 3, and this is not e, so it's gonna be e to the right negative 3c, so it's gonna be c. So the answer is C. Yeah, some might wonder how did I get the e to negative 3c, because like if you look at the finding the derivative, you're constantly getting e to negative 3x as your like result if you find the derivative, right? Which is why we express the e to negative 3x, but like since we're finding at the point of c, that becomes e to negative 3c, and then negative 3 is constantly getting squared or like triple or quadruple, which is why we express that as negative 3 at m plus 1. And if you plug it in the value, that actually works. So that's how we get C for the answer. Okay, this question has used the power series to find the power series representation for the function 5x to the 6 ln m1 minus x. So we are given ln 1 minus x. Thankfully, we are given that as negative k equals 1 to infinity xk over k. Okay, so if you want to make it into 5x to the 6th power, you can just multiply, right? So 5x6 ln 1 minus x is equal to negative k equals 1 to infinity 5x6 xk over k. And you can take out negative 5, right? So take out 5 outside, so this becomes negative 5, k equals 1 to infinity, and then x6 and x6 times xk is written as 6 plus k over k, right? You can write that like that. So then this just becomes the answer B. So the answer is B.